Hey everybody, I'll be with you in a second.
Oh shit.
I think we just had homework number 95, if that's correct. So we're going to have homework number 96. We're on this page, 32620, trigonometric function 7.3, properties of trigonometric functions. So on the unit circle, sine of theta is y, and cosine theta of x, and tangent of theta is y over x. Cosecant theta is 1 over y, the reciprocal of sine, so y can't be 0. Secant of theta is 1 over x, so x can't be 0, they're reciprocals. And cotangent is reciprocal of tangent, so it's x over y. So they want to find the domain and range of each of them. It's kind of confusing, and I'm not sure that it's that important to get stressed out about. But what it says is, for sine theta, the input is theta and the output is y, because sine is y. That means the domain of the sine is all real numbers. We know that the sine function just goes like this and it goes on forever. And it's all real numbers. And the range is between -1 and 1. Because it goes up and down from -1 to 1 to -1 to 1 to -1 to 1. Well, the reason why it stops at 1 is I wrote u. Y can never be bigger than the radius of the unit circle. If the radius is r, is y, is 1, yes, I'm having a good day. If the radius is 1, y can't be bigger than that because it's the y value of a point on the unit circle. The r is 1. The x and the y would be less than 1. For cosine, the input is theta. So this is all real numbers. And the output is x. So it's the same thing as sine, that the domain is all real numbers and the range is between -1 and 1. X can never be more than 1, the radius of the unit circle. For tangent, it says the input is any angle that does not produce division by 0. Because if you're looking at the unit circle, like this is 0, 1, right here, and tangent is y over x, right here. It says y over x. Y over x would give you 1 over 0, which is undefined. Or right here, 0, -1, -1 over 0 would give you undefined. So it means the domain is all real numbers except for odd integer multiples of 90 degrees, or pi over 2. Because you could go to, it says the range is all real numbers because the graph, you don't know what the graph looks like yet, but the range is all real numbers. But multiples of pi over 2 would be like odd multiples, pi over 2, 3 pi over 2, that's down here, 5 pi over 2, that's back up there, ... They're on the y-axis, and x equals 0, and that's when it would be undefined. But the domain, the range is all real numbers. for cotangent, the input is theta and the output is x over y instead. So this time it's these two places. 1, 0 and negative 1, 0 because it's x over y. So you get 1 over 0 undefined, negative 1 over 0 undefined. That means the domain of the function is all real numbers except integer multiples of pi. 0, pi, 2 pi, 3 pi, etc. And the range is all real numbers. Because this is 0 and this is pi, and then we're back to 2 pi, 3 pi, 4 pi, 5 pi. It's all the multiples of pi. And then cosecant is any that theta does not produce division by 0, and it's 1 over y. So for cosecant, it says except for it's all integer multiples of pi. And this would be dividing by y when y is 0. So that's same as cotangent because we just had dividing by y. And this one for secant is same as tangent because the input is theta where we don't divide by 0. The output is 1 over x. So that's the same as tangent because tangent is y over x. So the domain of secant is all real numbers except odd multiples. It's the same as tangent of pi over 2. So, and it says the range of secant and cosecant. Cosecant of theta is less than or equal to negative 1, or cosecant of theta is greater than or equal to 1. And when we graph, you'll see why that's true. So here, the range of secant of theta is less than or equal to negative 1, or secant of theta is greater than or equal to 1. And the reason for that is because they're reciprocals of the sine and cosine values. All the sine and cosine values are between 0 and 1. If you take the reciprocal of 1, you get 1. If you take the reciprocal of negative 1, you get negative 1. If you take 1/2, because that's a value of cosine or sine, when you do the reciprocal, you get 2, which is greater than 1. So it's because they're reciprocals of sine and cosine. And like I said, this isn't the most important section that we're going to do. Here we go. We're finding the period of trig functions. So we had cosine of 420 equals cosine of 60 because we subtracted 360 away. And we know that one revolution around the circle is 360 degrees. So the reason why 420 and 60 both have the same cosine of 1/2 is they are coterminal angles and terminate at the same place on the unit circle. Because 360 degrees or 2 pi, so just 60 plus 360 equals 420. Just one revolution of 2 pi more or 360 degrees more will give you a coterminal angle. So it says sine of theta plus 2 pi k is sine of theta plus 360 degrees k equals sine of theta. So if you add 2 pi or multiples of 2 pi, or you add 360 or multiples of 360, you still get sine, the original sine. And then same here, you could add multiples of 2 pi, where k is any integer. And this is 360k. You can add different 360s, or you could subtract 360s and go in the negative direction, and that would be equal to cosine theta. So it says, I'm going to stop the video and start it again because it's getting too long.